Hi, my name is Ashish Khaitan. This is a joint work with Siwong O at UIUC. In this work, we are interested in estimating a spectrum of a data matrix from a few entries. There are many examples where we observe only a partial observation of the original data matrix, example recommendation system where not all the users rate all the movies, or crowdsourcing where not all the workers answers all the questions. Mathematically speaking, we have a matrix M of size D cross D and rank R, and we observe a subset of its entries, and we want to estimate a spectrum of this matrix. Concretely taking an example with D equals to 1000 and rank R is equals to 100, with all the non-zero singular values being equal to 10, we have the histogram of the non-zero eigenvalues on the right hand side. If we observe sufficiently many entries of this matrix, that is above the matrix completion threshold dr log d, then we can simply scale each entry of the observed matrix with the probability of observation, and taking histogram of the scaled matrix gives us a good estimation of the histogram of the original matrix. But what if the number of entries observed are below the matrix completion threshold? The above approach doesn't work and we do not get a good estimation. But are there other algorithms that can work below the matrix completion threshold to get the spectrum of the matrix? That is the question we ask in this work. We consider Erdős-Rényi sampling scenario, that is where each entry of the matrix is observed IID with probability P. Our main building block in estimating the spectrum of the matrix is through estimating kth Schatter norm of the matrix. Given first k Schatter norms of the matrix, spectrum of the matrix can be estimated accurately. Kth Schatter norm of a matrix is defined to be singular values of the matrix raised to the power k and summed across. In this work, our technical contribution is in estimating Schatten k norms of a data matrix from its partial observation. We give efficient algorithms for estimating kth Schatter norm of the matrix and prove that given dr to the 1 minus 2 over k number of entries observed IID, we can estimate kth Schatter norm of the matrix approximately correct. We compare performance of our algorithm with the baseline algorithm, that is a scaled matrix approach, and matrix completion algorithm, and it shows that our algorithm works much better than the baseline approaches when the sampling probability P is below the matrix completion threshold. On the x-axis we vary sampling probability P, and on y-axis we have multiplicative error in the estimated value of the kth Schatten norm, and it shows the red dots correspond to our algorithm, the black ones correspond to matrix completion approach, and the orange one correspond to the scaled matrix approach. Full paper can be obtained at this archive link, and we have a spotlight presentation on Tuesday at 11:50 a.m. and we have a poster on Tuesday evening. Please drop by. Thank you.